ओम स्थापकाय च धर्मस्य सर्वधर्मस्वरूपिणे अवतारवरिष्ठाय रामकृष्णाय ते नमः. Namaste, my name is Harshvardhan. So today I will be doing a presentation on Suryasiddhanta. So the book I will be referring is that of Suryasiddhanta, translated by E. Burgess and edited by Fanindralal Ganguly, with an introduction by Prabodh Chandra Sen Gupta. So Suryasiddhanta is an ancient Hindu astronomical work with a unique pattern of verses composed of 2 lines, each broken into 2 halves of 8 syllables each. So it's a work which gained international attention due to its constants, equations and calculations being mysteriously nearly accurate despite of being so ancient. So it is also classified among the 18 revealed Siddhantas. So talking about the 18 revealed Siddhantas, there are 2 peculiarities in front of us. So the first one is that these Siddhantas were not actually textualized but first revealed to a particular person by a divine being. So in our case it is Suryadeva to Mayasura. Another peculiarity of these so-called Siddhantas are that the authors who have textualized it have actually hid their names. The main reason of it is to make these Siddhantas available for everyone in this world, irrespective of their caste, creed and color. So talking about its origin and authorship, it's a matter of several controversies. Several scholars have given their research to finding the origin of Suryasiddhanta. The most recent one is that of Nilesh Nilkandok. He is an author, an astrologer and an astronomer, and the date proposed by him goes back to 14,500 BCE, nearly at the end of Satyuga, strengthening the claim that Mayasura was the first author. Another scholar is Burgess himself. So the lowest limit of its composition proposed by him goes back to 490 AD, and the highest limit is AD 1091. So from all these controversies confusing the true existence of Suryasiddhanta, our introductor, that is Prabodh Chandra Sen Gupta, sums up these 3 conclusions about the stages of Suryasiddhanta. The first one is that the original Suryasiddhanta existed way before Varahamihira. The second is that Varahamihira did only redact with the epicyclic theory in it, and later additions and alterations were done throughout time.
Who was Varahamihira?
He was an ancient Indian astronomer. He has composed a book called Panchasiddhantika, and the reason for specifying his name is that because in his book there's a part, his astronomy, in the Panchasiddhantika we can find a section called Suryasiddhanta. So basically another claim is that Varahamihira was the first author of Suryasiddhanta, but as there are several other controversies confusing and opposing this claim, it cannot be accepted by certain people. So these 3 conclusions were summed up by the introductor. So to strengthen his third conclusion, the introductor gives us a series of evidences, of which the first one is the astronomical constants compared. So in here he gives us a series of tables, namely 7 tables, of which 2 I have written in here. And according to these tables, it can be concluded that the constants used in Kandagadika, an astronomical treatise written by Brahmagupta, an Indian astronomer, were derived from Aryabhatta's midnight system of astronomy, namely Artharatriga. Varahasiddhanta, similar to Kantakadika, was written by replacing and improving some of the oldest Suryasiddhanta's constants with that of Aryabhatta's midnight system. Therefore, it is evident that the original Suryasiddhanta existed way long before Varaha's time, and Varahamira was one of the few individuals who enhanced and updated it. Another evidence is that of the planetary theories in the modern book. So the introductor explains that the traces of the oldest structure of the Suryasiddhanta can still be recognized through the two distinct planetary theories mentioned in chapter 2. So the first planetary theory is still unknown, but the second is concluded to be the regular epicyclic theory. To elucidate this, he analyzes and explains some of the stanzas in chapter 2. So the explanation of the first 8 stanzas depicts that the planetary motion is caused by 3 entities, namely the Mandocha, that is the planetary conjunction, the alignment of planets throughout time. It's the Sigrocha, then the Mandocha, the apsis, either the farthest or the nearest point of an orbit from a planet to its primary body, and the Pata, and the ascending node, the point where the orbit of Sun and Moon meets, Rahu. So these 3 entities are the causes of planetary motion. Another line also explains or states that the chords of air create the forward and backward motion of planets, as these motion entities. The Sigrocha, that is the planetary conjunction, the alignment of planets, toward time. So they basically align at a line, they align at the solar system in their orbits. Then the Mandocha, the apsis, apogee, perigee, apopsis, and the periapsis. So, and perigee is a point where Earth is at the nearest to the Sun, and an apogee is a point where Earth is farthest, and the ascending node that I already explained. Another line explains that a pravector, a pravaha, impels the planets towards these apses, and that the excess and deficiency are the results. Additionally, the introductor describes how the Mandocha, Sigrocha, and Pata affects the mean position of planets. So after this, we obtain a conclusion that this system is quite prior and distinct from the epicyclic theory. So the epicyclic theory is pretty ancient. So if there was another theory ancient than the epicyclic theory, it would be at a time of Satyuga, also strengthening the claim that Mayasura was probably the first author of Suryasiddhanta. The next 3 stanzas were abandoned by the introductor as he considered them unimportant, and the 12th and 13th stanzas were explicated. So these poetic verses depict that the 8 planetary motion, detailing the retrograde, somewhat retrograde, transverse, etc., are the causes of planetary motion. Now, what makes these verses so important to the introductor's objective is that these verses are repeated across the whole text after being mentioned here. So as per Burgess, it is gratuitous. But the introductor says that these verses are the remnants of the first Suryasiddhanta artifacts. To strengthen this, he raises a quotation of Brahmagupta from one of his literatures, which cites that a person who claims that Aryabhatta knew the 8 planetary motion is incorrect. As further evidence for his attribution of these verses to the oldest Suryasiddhanta, he points to the inclusion of 2 planetary motions also found in the Panchasiddhantika, describing the Grahachara, courses of planets. The next stanzas, that are the 14th and 52nd, is explicated by him. The 14th stanza sums up that all these three entities, that Mandocha, Sigrocha, Pata, and namely, and these rates of motion, the retrograde, somewhat retrograde, are the causes. All are the causes of the motions in planets. Okay, so this theory is basically an outdated understanding of planetary motion, probably based on the geocentric model. So the geocentric model is a model of the universe proposed by Ptolemy, an ancient astronomer, in which the Earth is the center of the universe and the sun revolves around it.
The Indian astronomers know about the geocentric model?
Yes, that's not clear, but they did know, because this planetary theory is based on that model. Now, in this case, according to the introductor, one would naturally expect the author to give other equations, constants and tables related to the topic. However, the supposed interpolator breaks the connection between them by inserting some other informations borrowed from Aryabhatiya. Because of this, we spot an addition of 37 stanzas between the 14th and 52nd verses. So in the 52nd verses, a different planetary theory is presented, which counters the 14th one. That's why there is two distinct theories which counters each others in the same chapter. This theory suggests that the planets are moved by a celestial force, more likely a god, and using the slack air cords. So basically, the gods put a rope in the planets and pull them, and the rope is made up of air. So it can be confusing as two distinct planetary theories exist in one book. The reason behind this, as explained in the introduction, is that these stanzas are remnants of the oldest Suryasiddhanta. So the reason why the interpolator allowed these stanzas to remain in this book is still a mystery. It could be an error or some other unknown reason. According to him, it is likely that the 14 verses the recently added one, because it is more accurate and it overpowers the second verse, 52nd verse. So from all these above instances, it should be clear that the Suryasiddhanta was a composite work.
Was it?
Composite work. So next is the evidence of astronomical equations. Here the editor analyzes some equations from the Suryasiddhanta of Varaha. The goal is to show that the equations in question was partially borrowed from another author. So he presents two equations, that is the instantaneous daily motion of planets and the instantaneous daily motion of star planets, the sun, moon. So from the calculations done by him in that book, it should be clear that the Suryasiddhanta of Varahamihira had borrowed its constants from Lalla's. Lalla is also an ancient Indian astronomer. From Lalla's literature, which Lalla obtained from his teacher Aryabhatta. Therefore, these instances prove that the modern Suryasiddhanta developed into its current state at the time of Brahmagupta. There may be several other instances that need to be researched to solve the story behind the book.
In which era Brahmagupta was?
He's he's around 628 AD.
And which was the era of Aryabhatta?
That I don't know. I have not looked. So next is the evidence from the polar longitudes of junction stars. So junction stars, also known as polar stars, are basically the stars located at the celestial north pole, near to the axis of the earth. So the evidence of these,
They are called junction stars?
because they are at the axis, the celestial axis of the earth. So by comparing these polar longitudes, the introductor wants to calculate the upper and lower limits of the dates of Suryasiddhanta. So the upper limit is calculated by comparing 6 stars given in Brahmagupta's literature and Suryasiddhanta. The comparison shows an excess of 3 degree 23 in Brahmagupta's work, which at a rate of 72 per years per degree is the excess of 244 years. So I already told that Brahmagupta's period is known to be from around 628 AD. In that case, the year of or the date of Suryasiddhanta becomes 384 AD. However, the introductor sets it down as 400 AD. So the stars taken into consideration for this calculation were Kritika, Rohini, Punarvasu, Purva, Falguni, Maga and Chitra. So the lower limit is calculated by finding the mean excess in the literature of Brahmagupta compared to that of Suryasiddhanta. The excess is turned out to be 1 degree 15. This may be taken to correspond with 90 years after the time of Brahmagupta, and the date comes out to be around 718 AD. Thus, we can conclude that the Suryasiddhanta became a composite work from around 400 AD to 718 AD from this star table alone. So the method used by the introductor is more correct than the method used by Burgess. So the method used by him is just to quickly analyze the whole Suryasiddhanta and just to calculate in approximation and give the date. So it can also be inferred that the Suryasiddhanta existed way before 400 AD but in an amorphic condition. Varaha could have been the one who crystallized it and updated it by adding and improving some of its constants. So there are some other evidences to show that Suryasiddhanta was frequently updated and revised. One of them being the Bengali edition of Suryasiddhanta which reveals 21 extra stanzas in chapter 14 from verses 23 to 24. And then another is that of Ranganatha. Ranganatha is an commentator. It's an astronomer and a commentator who has done a lot of commending works in other fields. His version of Suryasiddhanta consisted of precisely 500 verses, extra 500 verses. So next, the introductor uncovers the evolution and the history of Indian astronomy, starting from the Vedic period, that is around 3900 BC, to the arrival of Suryasiddhanta and other astronomers like Aryabhatta, Lilla, till 800 AD. So the motive is to analyze the astronomical progress of India so far. So these are the periods as classified by me according to their improvements and development. So the first is the foundation of Hindu astronomy. So the great evolution of Indian astronomy began with the formation of the lunar calendric system. This represents a set of 12 synodic months integrated with solar years, which lunar calendar is a calendar based on the motions of moon. Okay, so this system proved its efficiency in tracking lunar months. However, it caused an issue where the total days of the lunar months mismatched the total days of the solar year, leading to an imbalance in seasonal, agricultural and ritual planning. So to resolve this, our ancestor annexed intercalary months every 5 solar years. So the next period is named as further improvements from 2450 BC to 1400 BC. So in this period, people began to use stars as their main navigational source. So further improvements in the astronomic field led to better accuracy in tracing the equinoxes and solstices, improving the intercalary month cycle.
What is equinox and solstice?
So equinox is a point of the Earth's orbit where the sun gives us equal amount of day and night.
Equal amount of?
Day and night.
Equal amount of day and night means?
The day is longer and night is short.
It gives us equal amount of day and night.
This day and night will be having equal amount of hours. Hours will be equal like this.
It's not like this, but it is shown that it gives us equal day and nights in the polar, in the North Pole and South Pole.
What is the meaning of solstice?
Solstice, it gives us more day. In one solstice it gives us more day, and in the other it gives us more night. Another period is named as a big leap, which is from 1400 BC to 200 BC. In this period, Tidis were adopted as a new time unit, probably shaping a full moon based calendar.
What is the meaning of Tithi?
A full moon based calendar.
Calendar.
That revolutionized the field of astronomy. Another major achievement during this era was the discovery of 9 planets and 12 zodiac signs.
Who discovered those planets?
That's unknown.
Indian astronomers.
Yes. This is the evolution of Indian astronomy. Another period is of misconceptions. The astronomical data gathered from 300 BC to 200 BC is comparatively limited. So according to Arthashastra, the only progress of astronomy during this period was the discovery of Grahachara. It means the discovery of Grahachara means that planets actually move, they are not stationary. However, the majority of misconceptions like the flat earth theory and the dual sun and moon theory seals this era as an era of misconceptions. Another period is unveiling mysteries and probabilities. In the period from 800 AD to 400 AD, the author suggests a 300-year-old gap in the astronomical development of India. While he proposes the potential arrival of the Babylonians and Greeks during this period, actual historical documents do not support this argument. He also proposes the potential arrival of the Suryasiddhanta in this period. So he is basically saying that Suryasiddhanta is not of Indian origin, it's from probably a Babylonian source.
Who is saying?
Prabodh Chandra Sen Gupta.
He is saying like this.
Another fact strengthening his theory is that Mayasura is probably of a Babylonian source. He is a Babylonian. And also at the Vedic time, the whole earth was Hindu. So it's Vedic. So it's normal at that time. The arrival of Suryasiddhanta advanced the astronomical field of India, leading to the birth of bright minds like Aryabhatta I, Brahmagupta, Varahamihira, etc. Opinion as to its dates and authorship. Now we will quickly review the various controversies and possibilities surrounding the origin of Suryasiddhanta. So the first one is according to Al-Biruni. According to Al-Biruni, the astronomer Latadeva authored the astronomical text, that is Suryasiddhanta. However, Latadeva lived around 499 AD, and the astronomical system used in his works is different from that of Suryasiddhanta. So he suggests that Suryasiddhanta may have existed before Latadeva's time and possibly even before Al-Biruni. Another is Nityananda. He is the author of Siddhanta Raja. Okay, according to him, the Suryasiddhanta was composed during the period of Aryabhatta in 499 AD. However, there are certain rules in the Suryasiddhanta for calculating specific objectives that seem to be added later. Additionally, some of the calculations in the Suryasiddhanta reflect similarities and influences from other astronomical works, such as that of Brahmagupta. Therefore, it is likely that the Suryasiddhanta existed before them. Another is Munishwara. He is an Indian mathematician. So according to him, the Suryasiddhanta was written by Aryabhatta himself. Although there are several similarities between the Suryasiddhanta and the literature of Aryabhatta, the significant differences between them cannot be ignored. Therefore, it is unlikely that Aryabhatta would have composed two books on astronomy distinct in calculations, method of solving problems and other aspects.
What is his book name?
Aryabhattiya. So the origin of Suryasiddhanta is still a mystery to mankind, but it has been proven that the book existed long before the currently known history of Indian astronomy. It played a significant role in the development of Indian astronomy. So next is a section called Further Indebtedness of the Modern Suryasiddhanta to Brahmagupta. So there are several hidden contributions of Brahmagupta in the development of the modern Suryasiddhanta.
What was the time period of Brahmagupta?
628 AD.
Does he have any relation with Aryabhatta? Like he is disciple?
There is a theory supporting that probably Brahmagupta was a disciple of Aryabhatta, but it is not proved. Okay, so although there were several other instances that proved the hidden contributions of Brahmagupta, the introductor only mentions the role of finding the sun's altitude, which he considered significant. By analyzing the similarities between the rules presented in both astronomical texts, we can predict the latest redaction of the Suryasiddhanta. According to his research, the period of Brahmagupta was from 598 to 668 AD. As it is been proven that the rule of finding the sun's altitude was borrowed by the modern Suryasiddhanta from Brahmagupta, the latest redaction of the book is likely to have occurred after the time of Brahmagupta. The originality of Hindu astronomy. So, even though the field of Hindu astronomy has been a subject to many controversies regarding the hidden contributions of Babylonians and Greeks, it would be inaccurate to state that the origin of Hindu astronomy is derived from these foreign systems. Rather, the introductor argues that the astronomic system of India was developed during the period of Aryabhatta, and that the interactions with these foreign systems only helped to further develop it. To support this argument, the introductor goes on to present several pieces of evidence that highlight the originality of Hindu astronomy.
When did the foreign connections in astronomy started with India?
That is the unknown.
It is unknown.
And it's not exactly proved that this happened, but there's a theory.
Those periods before Christ, some periods we believe. Those periods there was no connection between foreign astronomy.
No, there were not. No.
No connection. But in those times also our astronomy was developed.
Yes, it was, but at the
How can this author can give some kind of opinion that outside influences came and then our astronomy got developed? Because earlier periods also our astronomy was developed.
okay, he didn't say that the Hindu astronomy was only a subject of the Babylonians and Greeks. It just helped further develop it. It was already developed, but it helped further developing the field. So, for instances, the Indian astronomers provided less detailed astronomical descriptions, which shows that they developed their system independently. Additionally, the values of astronomical constants in Hindu astronomy differ from those found in Greek astronomy. So, if Greeks and Babylonians would have helped us fully to develop our astronomy, they would be our and their systems would be the same. Furthermore, Hindu astronomy employs distinctive methods and techniques that are unlike those found in Babylonian or Greek astronomy.
Can you give me an example of this? Do you know an example?
No, I don't know. Overall, the evidences presented by the editor suggest that Hindu astronomy is not merely a copy of foreign systems, but an original and distinct development in its own right. So this is the overall conclusion. So in my opinion, the Suryasiddhanta is a crucial text that helps uncover the lost history of Indian astronomy. It deserves further thorough research with a strong national response. To achieve this, India's brightest minds should focus more on our traditional scientific text rather than relying on foreign sources. They should adopt a nationalistic outlook and they should have a strong will to contribute to their nation's scientific growth. They should give more importance to their own nation's work. It's important to remember that scientists, astronomers, astrologers and other professionals must have a comprehensive knowledge of their own nation's ancient scientific literature. So with that, I wind up my presentation. Hope you all enjoyed it. Thank you.